Thank you for choosing DiQual, and welcome to our podcasts. Before we start, please don't forget to like, subscribe, comment, and share. It is really important to us. Hit that notification button as well, because there is more to come. You can get more detail about DiQual and our courses on our website at www.mydiqual.com. We hope that you enjoy this one.
This section is Security Practitioner 200. Artificial Intelligence, Data Analytics, and Deep Learning. And this is Artificial Intelligence.
Artificial intelligence, or AI, is the name given when a computer system is able to perform tasks such as visual perception, speech recognition, decision-making, and pattern recognition. Artificial intelligence is defined as an apparent intelligence that behaves in a similar way to a human. A system that uses artificial intelligence can appear to think like a human, but it will probably still look like a computer. If a system is said to have artificial intelligence, it is not necessarily thinking like a human. It is performing a data processing task that in the past, only a human could do. Modern high-power computer processing and programming languages now allow for some of these tasks to be done by a machine. AI is the facility within a machine to apparently think for itself. A good example of AI is that of a self-driving car. Otherwise known as an autonomous vehicle, because it uses search and planning to calculate the best route, it appears to look at its surroundings and make decisions based on its perceptions. It is not necessarily thinking like a human, but it is carrying out tasks that in the past, only a human could do. It is true that humanized AI can show characteristics of all types of human data processing, such as cognition, emotion, and social intelligence, but there are different levels of AI. Some systems are more human than others. Facial recognition is a prime example of AI in the real world. It can be used for identifying known individuals to grant access to enter an area, it can be used to open a smartphone, or it can be used for many other visual verification or identification purposes. Many countries use it at border control as part of the e-passport process. Facial recognition is a system that captures an image of a person's face, and analyzes it to see if it matches any known files within a database. If there is a match, then a positive identification has been made. The system creates a biometric map of a face and stores the data as an alphanumeric code. The algorithms required to scan the visual data and interpret it to recognize up to around 80 different measurement points requires a level of AI, i.e., the computer is looking at the image of the face and is trying to recognize it. In 1950, an English mathematician called Alan Turing proposed a method of testing to establish if machines could actually think. I.e., can a machine have intelligence? Artificial intelligence. He was confident that one day machines could be programmed to attain skills that could rival human intelligence. This was at the time when computers were only just emerging in the world as powerful computational machines. In 1953, Grace Hopper developed COBOL, which is recognized as the first computer language. Computer chips, or integrated circuits, were not developed until 1958. This means that Alan Turing was thinking about AI before programming languages and computer chips were available. The Turing test was devised to see if a human could be fooled into thinking that they were communicating with another human, when in fact they were communicating with a machine. The conversation was limited to text only and the human was shielded from the machine, so that they did not know who or what they were texting. The human would ask questions and the computer would answer. If the human believed that the answers were coming from another human, then the machine passed the Turing test, and in Alan's view, this indicated that it showed signs of intelligence.
At this point in the text is a photograph of Alan Turing, and a diagram of his Turing test, that shows a human shielded from a computer and another human. The two humans do not know if it is the computer or the other human answering the questions.
This basic test would be blown away by modern chat boxes and automated telephone systems with speech recognition, but the point to this story is that, putting science fiction to one side, artificial intelligence was being taken very seriously more than 70 years ago. Logic versus probability. Logic works with unconditional certainty, i.e., 1 + 1 will always equal 2. Whereas probability works with uncertainty, i.e., things most likely to happen. Logic has rigid rules that determines an outcome of an event based on definite inputs.
Here, in the text, is a table that describes the following pseudocodes. True is a mathematical 1. The JavaScript is the text true. False is a mathematical 0. The JavaScript is the text false. And is a mathematical caret. The JavaScript is a double ampersand. Or is a mathematical inverted caret. The JavaScript is a double vertical line. Not is a mathematical not sign. The JavaScript is an exclamation mark.
Probability is the foundation of judgment, which is the ability to make a considered decision based on varying inputs.
There is a diagram at this point in the text. It represents how a variance of less than numeric 1 can still result in a fixed output. The smaller the variance, the more certain the outcome prediction can be.
Artificial intelligence uses a combination of logic and probability. It is very difficult to pass the Turing test with logic alone. Therefore, introducing logic to constrain probability, it is possible for certain deductions to be taken seriously. For example, and in very simplistic terms, if you add flour, water and yeast together and bake it, in all probability you will get bread, because logic dictates that these are the correct ingredients. If you remove one of the ingredients, logic will dictate that you will not get bread. However, the formula of flour, yeast and water does not account for individual quantities or baking temperature and duration. Therefore, you will only probably get bread, but the predicted outcome of bread is based on logic. This combination of logic and probability is called the probabilistic model. A probabilistic model combines logic and probability to take random variables, which are the potential outcomes of an event, and combine them with the statistical likelihood of each outcome. Probabilistic programming can help us analyze large amounts of data in a way that goes beyond pure logic. In a pure logic model, 1,000 bits of data could represent a defined outcome. However, if just one of those bits of data were inconsistent with the model, then the outcome would be false. In a probabilistic model, 999 bits of data out of 1,000 being correct, would give a true outcome, and the chances are it would be right.
That completes this section of audio. We try to keep narration short, because there is a lot of information contained in this section. If you want to, you can listen again, or read the section and switch between text and audio. When you are ready, you can proceed to the next section or subsection within the module.